Yeah, I just wanted to say thank you to the organizers already because to put us in this awkward position to be the last speakers. No, thank you not. But even with this extremely broad material that we have listened to the last 2 days, I think we still do something that has not been mentioned yet. And I'm really surprised at the broad scale of this conference. So I just wanted to comment on it. That is really, really cool. The work that we present is shared work with our colleague Alex Kaye, who is attending via Zoom. And this is Raphael. I'm Malte. And I have the honor to start the thing off. And as you can not yet see, but have maybe read in the title, what we are interested in is to get to new types of sources. So we always talk about approaches. We have large language models, but all of that is relying on what is available. So what can we base our work on? And we want to actually present an experiment. So we should clearly state this is not finished work. This is just a proposition of what we could do. How we can tap into new types of sources for our type of research. And this is what we want to say. So as you can see, I don't want to say anything. We have already touched on the concept of knowledge graphs, and we will go a bit deeper into it. But the main difference I see with previous talks is that we don't want to use an LLM or to only look at the LLM, but actually it's machine learning is just part in a chain of so to say dealing in a pipeline way. So we are not interested in the perfect large language model, but we are interested in the most useful one for a specific task. So and that's now I'm blood enough. Okay, I can just continue generally paraphrasing. So the sources that we normally deal with in HPSS are already structured. So we have some publication databases, or even if it's an email archive, we have some sort of composed structure already. But the benefit that we saw in using LLMs is to be able to put structure in unstructured data. And that is actually, since a very long time, something that we did with Gerd Grashoff, for example, in the past, that you have printed books that are absolute, so to say, the main core of an idea, but we can't access them computationally. So you can't read 5,000 pages, but you know it is the source. You have to, if you want to understand something about handwritten records, you have to go to this book. But digitizing it, and so to say, the source material that we had in mind when we started this project are actually biographical sources. So sources that are extremely rich in what is in them, and you can get a lot of information about a certain person that might be of interest because of a certain, for example, phase in the evolution of physics. But the structure is not there. So we can't ask structural questions to this type of source material normally. And this is exactly what we want to use large language models for. So we want to use them to construct from unstructured data in a controllable way knowledge graphs that we can query to, so that we can, for example, ask not only how a certain person was born and where they did work, but how a certain profession in a certain period of time got into contact to other people, for example. How did they build networks? And we can ask such questions if you have structured data. And that is the knowledge graph concept, basically. So you have text parts that are printed in, for example, in a biographical book. And we come to the case studies later on. Or as you see it down, it's a Polish material, down a German source material, and we will introduce them later in detail. On the right, you see a representation in Neo4j. So you have entities, persons, places, countries, works, and each of those entities is a node in a graph. And if you find in a later part of your source material the same entity, you can create edges between them. And on this type of knowledge graph data, if you construct it nicely, you can ask structural questions. One of such an entry, this is a source material from around the 1930s. It's about evangelical priest Hendrik Bartsch, born 1832, as you can read, and he traveled. So he wrote some books on his travels, and that is why he was put into this biographical material. So you could say there are NLTK approaches, classical natural language processing, which we traditionally used to get structure out of this material. But normally, these approaches are not rich enough to give us the context of all of these entries. So if you think only on the first part of this example, it has a lot of structure. And this is now not known parts of speech tagging, but this is actually just entities that are statements that we can extract from this simple sentence. So what was his profession? When was he born? Where was he born? This city where he was born, in which central location was, administrative location was it? Where did he travel to? And so on. And to get to this to this type of structured data, that's the first part where our pipeline starts. And I hand over now until the next part.
Thank you. So I hope everything works now. So the question is now, how do we get all those statements Malte just showed out of these biographical text and then into the knowledge graph? And so we propose a two-stage pipeline, and the first stage is responsible for extracting any statement in a text, so without relying on any preset categories. And the second stage then constructs the graph out of these statements, and yeah, it follows certain rules, so to make sure that all the information is consistent and clearly categorized. And we build our pipeline on a few principles that distinguish it from other pipelines that are out there. I mean, we talked about it already. There's like Neo4j Graph Builder that basically does the same out of unstructured text, structured text, or the Microsoft Graph Rack, but they all have their own problems. So the principles we're trying to implement is first task decomposition, so breaking the process in very small, controllable, verifiable steps. Then we make it data and research question driven, meaning that the final graph structure is guided by our specific research aims. And then third, that the pipeline is verifiable at some key points. So the human in the loop aspect. So how do we operationalize it? The first stage, let's look a bit at the first stage of the pipeline. And the input data is often originates from very messy, unstructured sources needing then OCR or scraping, and after them pre-processing it. It enters the pipeline semi-structured. You see an example how it might look here. And then the first central step is that we use an LLM to do so-called open information extraction. It means we're asking the LLM to extract all subject, predicate, object triples it can find irrespective of any preconditions. And OIE, or open information extraction, is a very, very active field of research, and yeah, it almost also completely switched to using LLMs. Then the second step is, or in the second step, we use LLM ensembling by taking a second model that validates and refines these initial statements, and we prompt it to act like an adversary to the first model. So we ask it to be very critical of the output of the first model to correct errors and to find new triples, and then also give a confidence score for the extraction. And especially this second step improves the quality significantly. And then we evaluate a sample of the validated output against the same sample that is created then by a domain expert. So that's the first step of human in the loop. To then get the classical performance metrics and judge the quality. So if the score is high enough, we move to stage 2, and if it is not, we go back. So that was the question we had also on the first day. What is good enough? It's totally dependent on your use case and on your data set and what you want to ask it. So I said, let's move to the second stage, and this is about giving the extracted knowledge then some more structure. And here, the first step is that we define so-called competency questions, meaning questions we want the final knowledge graph to be actually able to answer. Why? Because we want the knowledge graph to be structured in a way that is fitted to our research question, rather than being ontology driven. So there's also a human loop step in there, but we let a reasoning model draft 25 to 30 questions. And then again, a human domain expert corrects them, refines them, and finalizes them. And then on top of this competency question, the next step, we built the ontology. So together with the competency questions and the already extracted triples, ontology is created. And again, a reasoning model drafts this ontology and a domain expert finalizes, refines it, and corrects it. And then from the ontology that is created and refined, we generate so-called shackle shapes. I mean, basically, these are rules. What kind of statements are permissible at all in this knowledge graph, dependent on the ontology we just created. And then in the last step, we disambiguate entities and resolve to Wikidata instances, for example, like I don't know, Humboldt UNIF Berlin to Humboldt Universität zu Berlin, or stuff like that. I mean, that was also already talked about. And then we encode the data and include some metadata, so the source data, the scoring data, and the initial chunk, and put it all together in an RDF star graph. And then do a last valuation, and then we can export it, for example, for network analysis to a graph database like Neo4j, or store it as a triple store to then do some reasoning later with it. And now I give back for the use case to Malte.
So the main idea of this is that we have a controlled approach, come from unstructured to structured data, and the type of questions we want to ask are overarching questions. And one of the corpora that we already showed a bit is actually coming out of earlier research, where we stumbled upon a dictionary that Jelinski compiled as a measure of nation building before basically the Polish nation became a nation, or during that process. And he wanted to get a list of like all of the Poles that went abroad and did exploration and so on. So you have this dictionary, it's printed in 1930, we have a PDF of it, but now we can actually ask structured questions. And these questions that we want to ask are, for example, how different individuals by their process of migration brought new ideas and how they became, for example, innovative in that other places of the planet, or how certain editors in that corpus played a role in the knowledge spreading. And this is the next graph that I will show is compiled by Alex. And it shows the network of editors in green and authors in pink. And this is something that is just not possible manually on this printed PDF. And we can then do an analysis of centrality measures also across time and so on, and get new information that asks this corpus something structural that was not possible before.
So another case we look at is the who was who in the GDR. It's a biographical reference work documenting around 4,000 key figures from East German history. And it's published since the early 90s and covers like politicians, dissidents, scientists, artists, and so on. And of course, it's biased in this sense because like the clear indication of being in this dictionary is famousness as a criterion. And in the 2000s, it was then digitized and published online. So you can search it. So you can search the text, but you can't ask structural questions again. And an example of a structural question we could now explore after running the pipeline is, for example, what differences exist between individuals who received state awards and those who did not, regarding their political affiliations and roles within the state. So again, this is a first experiment of an early version of the pipeline, so it's not the validated set. And we're working here with 1,000 randomly sampled biographies from the who was who. And what you immediately see here is that, I mean, some words like the Karl Marx Orden and Held der DDR strongly, of course, correlate with both SED affiliation and political power, and others like the Nationalpreis show an even weaker link to high positions than individuals without an award. I mean, likely because they were more often like awarded to cultural or scientific or athletic figures. So why is this interesting for HPSS? I mean, analysis of this type, not this particular analysis, but analysis of this type, are valuable because they allow us to structurally investigate the interconnection of science and politics. And by doing these kind of analysis, we can then examine how, for example, education or political affiliation or positions of power vary across different generations or cohorts of these scientists. So we get a glimpse into the dynamics of this relationship over time. So let's wrap up. So we go from isolated biographical entities to structural queries. And the main challenges that we face at the moment is improving the entity disambiguation and also proper benchmarking. We then will move on to refine and complete the pipeline. I mean, it's not completed at the moment. It's still a proof of concept, to be honest. And then compare it systematically to these other pipelines I mentioned earlier. And looking ahead, we would then like to use it for also GraphRag. I mean, taking this knowledge graph and the chunks we extracted to then build out a system where you can query the whole data set with natural language and to build multi-layer networks for a deeper structural analysis. Thank you very much.
Thank you, Malte. Thank you, Raphael. Are there any questions?
Not so much a question and a remark. Thank you very much for this brilliant presentation. Also very clear. Yeah, I really, really loved it. In the Daria ERIC, in this European kind of thing, there is a working group on bibliodata. Are you aware of that? You should get in touch with them. They should get aware of you. Yeah. And Tomasz Umerle from the Polish Academy and the Institute of Literary Studies is currently the chair of the working group. He's also part of the Joint Research Committee. So I can make it maybe that.
I mean, maybe Alex knows them. I mean, she's online here, so I don't know if, but please give us the contact.
So I think that would be nice. And the other thing is something I only darkly remember, but in the Netherlands, there were like decades of work into building a bibliographic portal. I remember seeing stuff 10 years ago in digital humanities. So, because I'm trying to dig that out. Yeah. But brilliant.
Okay, next question.
Thank you so much. And one great thing I think about this workshop is to see how problems are tackled and then how you could apply it elsewhere. So I'm building off that. Bibliographic data, old book catalogs, structured data, I mean, perfect, right? I'm trying to extract stuff from a 1792 book catalog and I'm having a lot of trouble. Maybe a lot of it's due to the poor OCR, but this is exactly the kind of approach that could be used, I imagine, for that, right? You have your entities, you have your structured data. How can I combine these things together to pull all of that out in a way that's highly accurate? So I just said that the applicability seems pretty strong there. And I wonder if you had any thoughts about that. Are the troubles you're facing, is it mostly due with the OCR of the 1930 text, or is it the trouble with the LLM ensemble, or where are the pain points pretty much? And how applicable could you use it in other structured?
Yeah, thanks for the comment. I mean, that's the great thing. That's why I think the first step of doing open information extraction is quite powerful, because you can apply it to various kinds of corpora. You can also apply to, I don't know, publications or abstracts to extract what you want and then build the ontology of what you want to ask. So I think the applicability is quite great. I think the hardest point is this open information extraction. And that's why, I mean, this research field that is moving fast, a lot of stuff is happening. There is a difference between sentences and documents. So if you want to do open information extraction across documents, it's quite hard. If you want to do it via sentences, it's pretty good already if you're using LLMs. But that is still, I mean, if you have these triples extracted quite well, then the rest is kind of easy. I mean, of course, it's not easy, but I mean, that's actually a hard part, to get like the contextual information out of it. Yeah.
To add to that, I think the interesting point is, once you have the triples, the point of building the knowledge graph is research driven, right? So you might have a publication of your triples that you extracted successfully, and then you make this open and you give it out there and have people ask completely different questions that lead to completely different knowledge graphs. And I think that is the interesting point of reusability and this kind of pipeline steps that are separated by their individual and with individual quality control, let's say. So this is really crucial. We don't always have historians of science looking at dictionaries. We also have, I don't know, family history or something like that. And that is really the cool thing.
Yeah.
Sorry.
Okay, yeah, there's another question. Please go ahead.
Reusability is a good point. Your use case is exactly what I was thinking about when I saw that Wikipedia has a lot of biographies and Wikidata doesn't in a lot of cases. So the ideal would be just to take all the knowledge that we have in Wikipedia and translate it in an already existing knowledge graph that is Wikidata. And I was wondering whether you were thinking about reusing some data or using some data from Wikidata to evaluate your own, or if you say there isn't anything, will you be thinking about contributing back? Or do you think this is the scope, out of the scope? And then the second thing is triples. I found the exact problem with statements is that they are valid for a certain period in time. So of course, if somebody was born in 1970, this is a timeless statement. But X traveled to Egypt was only true in 18 something. Yeah. So we need four. I mean, we need the time dimension. How do you model this?
I mean, actually, yeah, we do that. I mean, we extract. I mean, that's the great thing about these dictionaries, that we always have like a time stamp on the statements. So like there's always a sentence. Okay, X was there at, I don't know, this time. So we extract these triples plus the time if it's available, and then I mean we use an RDF star to model that later, and. But yeah, I mean, that's what we're interested in. I mean, we're interested in development. I mean, into looking how things developed, and that's why this time aspect is so interesting. But I mean, if you go to other genres, this might not be that is interesting to you. I mean, similar things are used on, I don't know, publications on deep learning to extract what methods are used, for example. And you can also do that by extracting triples. Then a time component is not as important, for example. Yeah, sorry. And the other question you ask is the Wikidata. Yeah, I mean, we're trying to solve the Wikidata, and I mean, it's early stages, so would be cool to actually also feed back something into Wikidata and look to other stuff. But at the moment, the goal is to actually get it on the road.
So thank you. It's a great presentation and very much aligned with what we do. And honestly, we already started to work with Wikidata. And my suggestion actually to consider something like Dataverse to archive this knowledge. So what we do in one of European funded project called MuseIT, we're getting graph, and this graph is being archived. So it's in fair infrastructure, so it will get persistent identifier, and it's highly reusable. So you can download, and you can put it in something like Neo4j, any kind of triple store, query, get some knowledge back, and put in LM in a context window. Okay. So that's something I think that can be also useful for you.
Yeah, cool. I mean, yeah, maybe we talk later.
Yeah, think
about that.
And there's one more question over there.
Yeah, thank you. One thought is maybe approach this also as a visual question answering task.
As a what? Sorry.
Visual question answering task. So just ask questions about what is what people are mentioned and what are you will think about how to formulate them, but as a visual question answering task. And also it's interesting for me, how do you pick relevant relations from this pool of relations that you have, and how do you disambiguate between relations? So does LLM, which is on top, do all of this?
Okay. I mean, that's the hard part to disambiguate. I mean, the two steps of open information extraction are already doing some kind of standardization, so that you, I don't know, that you don't have like an abundance of this similar predicates. But I mean, to resolve that is the step of the disambiguation, which is not yet at a, I don't know, super high level. But I mean, we got some inspiration here to maybe do it better. And the second part was?
So the question, looking at this as a question task, I mean, the interesting point is that the second step is exactly that. So you can't create the second step without research questions. So, but it's not like a question answer, like an LLM, not yet. It's not yet a graph rug, but it's actually the reason behind that is that each knowledge graph that we build is actually research driven. So we can't have a knowledge graph. I mean, of course, you can just use the Wikidata ontology, for example, but then it's ontology driven. And what we are interested in is to have a knowledge graph that is able to answer the questions that we want to ask. And that's why I would say this is the stage where we have the research questions that are really central.
Yeah, maybe. I mean, something different. It's just technically different approach to extracting data from your pages and just this.
I mean, like if we actually use vision models to extract the data right away, is that your question?
Yeah, just to use large models that can I don't know, visual language models that understand like the relationships within this page, like as an image and text at the same time, and just ask questions to this.
Yeah. I mean, we of course tried that, and I mean, for example, for the OCR, we also used like the new Mitral OCR system, which is pretty good. But I mean, the whole point of the pipeline is to do this task decomposition. I mean, you can do it. You can put a page in there and then ask a question or say, please extract all the triples you find in here, but it's just bad.
Not triples, information.
But I would answer it differently.
The information flow, yes, and just compare like how it will work, like compared to this two-step approach where you have open question answering, then you have an LLM which decides something. So yeah.
No, the point of so we have our motivation behind this setup is that each step has a individual quality control. So we are really getting away from any hallucination problems, and we can say what we input, and we have this methods, for example, of Shackle to define a quality control of our knowledge product. And then we are totally, at the end of our pipeline, we are completely gone with any machine learning. So we are purely in a graph and network-driven research. That is an argument of energy consumption as well. So we are completely out of machine learning at the end.
Yeah,
ideally.
just a small comment about hallucination, that you can avoid it that as well. Just take what is in the text.
Okay, one last question from Sophia.
Thank you. I really liked your presentation. I have one question and one suggestion. So the first one is related to the ontologies. Did you face any challenges where the ontologies were contradictory, or I don't know, there was an entry without ontologies and you handle it as a, let's say, entry not needed? Or what were the challenges there in processing?
I mean, the challenges, I mean, basically so far we did it by hand and we tried that first. I mean, the first version of the pipeline is not research question driven, but ontology driven, and we faced a few problems with that. Because if you if you go into that and to really define it very specific and very strict, if the ontology is too big, every model has its problems. And that is why we try to reduce the steps, and also why we think that building the ontology based on the questions is much better than having like a huge, I don't know, standardized ontology trying to extract everything that fits to this one.
Okay, thank you. And my suggestion is related to the future perspectives regarding disambiguation. The entity alignment task, especially with knowledge graphs, the graph convolutional nets are a possibility.
Yep.
maybe I can send you the paper I'm referencing here later.
Please,
Thank you
everybody,
very much.
send us papers if you have if you have ideas.